All right, folks. So what we have here is a kit build that we did over the last couple of days, and it is a signal or a function generator. Different folks call it different things, I guess, depending upon where you're from. A couple things I wanted to note in putting this kit together, which was relatively easy. I did add these standoffs, and the reason I did that is because there's component bottoms here. It doesn't come with a case, and this just makes it a little bit nicer, a little bit easier to work with on the desk. It has a variety of functions. It does a square, triangle, and sine wave, and then you can adjust them. Also, I added these leads, power leads. Each one of these leads is for the different waveform, and then this would be your common or your ground. After we build this in the video, we are going to hook it up to this particular oscilloscope right here, and we're going to take a look and see how well it does. So stay tuned, folks. Okay, so here is what we got in the mail, and it says made in China, and that is so small I can't read it without my reading glasses, so we're not going to read it. Let's open up this static bag and see what we have inside. Now immediately I'm concerned that one critical piece is missing, and that would be what we call instructions. But here's the PCB, and it does have markings where all the components go, so this should be a relatively easy construction or build job. I'm not too worried about that. This looks like it is a connection port that probably goes somewhere right about here. We're not going to take a look at all of these things, but here we have some teeny tiny resistors, some more, little capacitor action, potentiometer. I'm not 100% sure what this does. I think it adjusts the amplitude of the wave that you get out of here. And we have some capacitors, we have diode, LED. Man, these parts are tiny. These little teeny trimmers here. I mean, look at this. Look at that capacitor. I mean, that thing. I get that there's hams out there building smaller stuff, but this is pretty small. And a switch. Let's see if we can dig some instructions for this project up on the internet somewhere, because what I'm concerned about is I'm going to have some instructions, and I like instructions. I'm just going to go out and say it. So let's see if we can find some. Okay, so we searched the internet high and low, and this is the best set of instructions that I think that I can find. So when you take a look, it has the tools that you're going to need, some precautions. It has some nice pictures here of how things go together. Down here at the component list, I think I can read most of this. I don't know what a potent is. Maybe that's a potentiometer, but do we have that many of them? I don't know. And I guess ceramic cap, medium ceramic cap is what we're looking at there. These instructions also, when you take a look here, show you some ways that this thing can be set up and used, and it gives you some measurements along with a schematic. So this is pretty handy. I will keep a link to this below. One thing I'll say is that this is a relatively popular kit, and you can buy this off of all kinds of places for less than $10. I'll include some links below in case you're interested. This is Instructions Revision 1.0 from September 19th, 2016, produced by Yeekwee. Thank you, Yeekwee. But some of this may have changed since then. I don't know. I haven't compared these instructions directly with everything. But this is what we're going to use to put this thing together. So here's a link to where you can get one of these off of Amazon. I actually posted another Amazon link in the comments below where you can get this for $4.99, not $8.99. It does take a little bit longer to ship, but I wanted to show this one because it has better pictures. You can also find this thing on Banggood, or you can find it all over the place. So I don't know, $4.99, $8.99, it's cheap enough for me not to go looking anywhere else. I did want to mention this uses this chip, the ICL8038. And you can see that pictured here. Oh, I guess I'm not going to be able to do it down here. And you also see a socket for this chip. Now, the kit that I got did not come with that socket. So I thought I would just point that out. And here is a completed picture of the project. Here is a quick look at the data sheet for the ICL8038. And it says it's not recommended for new designs, but this is an old design that's been around for a while. I would suspect that the chip that I have is a clone or a counterfeit or a knockoff chip, especially at that price. Maybe I'm wrong about that, and I just don't know what I'm talking about, and that's okay. But I would suspect even if it's not, there's probably tons of these chips floating around, especially the clones and knockoffs, that people are using for kits like this. I'm not going to go through this. I did want to show here is the pinout for the chip if you're so inclined to look at that. and just a ton of information on the chip, but I wanted to show, here's the test circuit. And this is pretty much the design of the kit that we're putting together right now. So there'll be a link to this below also if you want to check it out. All right, folks, so we are going to start. We have this handy, I don't know what you would call it, gripping device over here to hold the board while we do some soldering and stuff like that. But they say to start with some resistors. So we have some of the resistors from the kit here. And what I want to do is I want to check the resistance of these resistors so I don't get them mixed up. They're definitely difficult to see. So let me just go ahead. And polarity does not matter on these resistors. So let me go ahead and test these. So that's 3234 kilo ohms. Let me just test this one down here and make sure that they're all the same. So it's 32356. Let me go back and take a quick look at the instructions and see what this is supposed to be. So these would be the 33K resistors. So I'm just go ahead and mark those. And then what we'll do is we'll look at the schematic, see where these belong, and then we'll put them in this board right here. Now let's go ahead and test these. So we know, I believe these are the 10Ks, but I'm not 100% sure. Oh, let me get this where you can see it. Sorry about that. Okay, let's go ahead and test these and see what we have. And we're right at 10, and we suspected that these were going to be the 10Ks. All right, we're going to go ahead and we're going to mark these 10K, and then we're going to get them on the board. Now, hopefully my magnifying glass makes this a little bit easier for everybody to see, but there you can see R2, R1, R6, and they're marked. R2 says 10K, and R6 says 33K. So that makes it easy to figure out what goes where. So what we want to do is we want to take one of the ones that we marked 10K, and then we're just going to remove it from here. Now, a lot of people like these to go the same orientation, and they get all worked up about it. So let's try to do the same thing here. Although I don't get as worked up about that. Okay, I've adjusted the camera, so hopefully you can see this a little bit better. And these are reversed. They're going the wrong direction, but I'm okay with that. So I have all the resistors on. I did the 10Ks, the 33Ks, and then up here is a 200K. So the next thing for us to do is break out the soldering iron and go ahead and solder. So what we can do with this handy device is that we can actually flip these things over, and then we can work through soldering each one of these through-hole components. After we flip this over, what we can do is we can concentrate on soldering each one of these through-hole components. So let's go ahead and get started on that. All right, it's not the best, but I've definitely done worse. Okay, I feel like an old man here. The next thing we're going to do is this D1 diode. And here is the diode that came with the kit. And you need to pay attention to these diodes because they definitely are polarized. So we're going to go ahead and we're going to put the band of the diode facing that direction. So let me go ahead and prep this, and we'll go ahead and we'll put it in. All right, let's see what's next. Okay, so what they want to do next is they want to use these capacitors, and here they are. Let me slide them up. And let me tell you, these capacitors are teeny, teeny, tiny, and what we have to do is we have to put these on the board. In the instructions, it does not mark a capacitance value for these capacitors. So I can't measure this and then tell you where on the board they go. But if we take a look here, you can see the marking on the board, like there's numbers. So this is capacitor 2 goes here, which is 104. Capacitor 4 goes here at 103, and so forth. And so hopefully you can see this when I hold this magnifying glass up. But there is a 104 on this capacitor. So I know that this one goes here at C2. Now, one of the things that you want to be careful about with your capacitors is that these have a ceramic inside to them, ceramic capacitors do. And when you bend the legs for soldering, you don't want to bend them very far, or you could damage the ceramic inside, which will affect the value and the performance of your capacitor. So I'm going to go ahead and mount these now. Okay, we're making progress. Let's see what's next. Okay, we are doing the LED this time. And so what we want to do is we want to make sure that we keep our orientation correct, because LEDs are polarized. So let's take a look at the magnifying glass, and you can see that. And so what I'm going to do is I'm going to take the long leg and I'm going to put it to the inside. And hopefully this works. Now, I had read about this kit, and some folks had said that the LED was incorrect in terms of its polarity, the way it was marked or its legs were. I don't know if that's true or not. So what I did is that when I soldered these, I left these legs a little bit long in the event that a repair is necessary. Okay, let's see what's next. Okay, this is probably the most difficult part of the project, but it's not too bad. And it's where we put on the IC. And so when you take a look at the board, you can see that to the right side of that, there is a notch or a key that is cut out. And that is so you know the orientation of the IC. If you can look here, you can see a little bit of a notch right there. So that way you know that your IC is oriented correctly. I think I did mention earlier that this particular IC or this kit did not come with a socket, which is something that you often would see. You put a socket down, and in the event that your IC is bad, you just pull that out of the socket. There's no need to resolder. But I guess somebody somewhere wanted to save 15 cents, so this is what we got. I want to make sure that this IC is in place and stays in place well when we do this soldering. So I'm just going to use a piece of this blue tape. Now, some folks may say, well, why are you using that blue tape, Ape? And it's because I can't find my blue tack. So this is what we're going to do. And now we're going to just flip this baby over. And then we are going to work through soldering these pins. Which is going to be a little bit of a job because these pins are small and they barely poke through, but with some perseverance, we should get this done and be just fine. Dang, you hear that wind out there? Okay, and the chip is soldered. One way to test, I suppose, is to take this tape off and see if it stays in place, and it does. Okay, we're going to go back to the instructions, and we're going to see what's next. Okay, next up is our switch, and this switch is used to change the frequency that you are generating a signal on. So you can adjust it from a lower set of frequencies to a higher set of frequencies using that switch, is my understanding. So what we're going to do is we're going to put this switch in here, and we're going to go ahead and we're going to use some blue tape to hold it down. Now I just need to find out where the heck that switch is, and it is right here. So let's go ahead and get to soldering. Okay, so I wanted to point something out. When I put the switch on here, you can see that those three center pins bridged. Part of the challenge that I've got is that I've got old eyes and I can't see exactly what I'm doing. So to finish out, we're going to be wearing the splaining glasses. Let me go ahead and get these things on. I'm not sure if that if that helps or not. But what I want to do is I want to try to get that off of here. So I actually took some time to find some of my desoldering wick, and we're going to go ahead and we're going to try to get that off now and then resolder it. So let's go ahead and get started. Okay, that looks a little bit better. I'm going to go ahead and take a picture, and I'm going to roll in a before and after, and then you'll be able to see the difference. So let me go ahead and do that. All right, I'm not sure if these glasses are helping or not. The next component that we are going to put on here is the fine potentiometer adjuster. There we go. And then what I'm going to do is I'm going to take a piece of my blue tape, and I'm going to put it on here to hold this baby in place while we flip it over. And we're going to have to go this direction for whatever reason. The spring is not cooperating. And so let's go ahead and get these three bad boys soldered. Okay, we just went ahead and we added the coarse potentiometer as well. The fine adjustment potentiometer is a little bit crooked, you can see right there when I do that. But we're going to be able to live with that. Let's go and take a look and see what's next. Actually, I already know. It is this piece. And so this is the piece where we adjust our power connectors and where we will be able to adjust or we'll be able to put in our connections that go to our scope. So you can see down here, like you have your sawtooth and your square wave. And this would go on like that. Let's see if we can go ahead and get this thing seated. And it's there. And let's go ahead and get this thing taped. All right, I think we're rounding the corner here. Let's see what else we have to do. In terms of parts, I know that I've got this capacitor and I've got these two potentiometers, so we can probably just figure this out real quick. Okay, I'm re-recording this because I had my soldering iron on, and the iron makes a bunch of noise, and it impacts the sound quality, so I just turned it off. And what it is, I put the capacitor in here. We should have done it earlier, and you need to pay attention to the orientation of the capacitor. Here you can see the negative marking, and that corresponds with a marking on the board. The other thing is that the short leg is the negative. So what I want to do is I want to tape this on here because I don't feel that it's in the best. So let's go ahead and just tape that, and we'll go ahead and get it soldered up. Next up for soldering, I already placed these, are our two trimmers. And you know what? These have different values, so I got to go back and check the instructions and make sure I did that right. Good catch, Ape. All right, and by the grace of God, we got them right. This is our 203 and our 104 trimmers. So let's go ahead and get those soldered as well. Now, they stay in pretty good on their own, so we're not going to have to tape anything there. All right, so I guess the project is done at this point. Let me go ahead and put this knob on here. And orientation for this knob really doesn't matter too much, at least to me. It turns that direction, but there's no markings or numbers or anything like that on here. A couple of things that we need to do is we need to get some power leads. It did not come with any, and then I'm going to need a couple of wires here for my ground, for my square wave, for the triangle wave, and for the sine wave. So let me go ahead and do that. The soldering doesn't look too bad. It's not the here's what I always say, it's not the worst I ever did. So so we're pretty happy with that so far. I'm going to put some standoff legs on here as well so I can just sit it on the table. I like to do that with these little kits. Let me get these ridiculous glasses off while we're at it. All right, I'll be back in a little bit. Okay, so what I did is I just made some jumper wires here with a kit that I had. We have our negative, our positive. This is a 12-volt input. So we're actually going to use a battery. Let's see. We're going to use this BioNO battery, which is a 12-volt battery, to go ahead and power this. I'm going to have to figure out where my connectors are for that so I can connect it to here. But then I also made jumpers for each one of the various sine waves. Now or each one of the waves. It's my understanding that they all are active all of the time. So we could probably use more than one lead on our scope to see more than one wave at a time. And then green is for ground. So that's done. This is the switch to switch between frequencies, and here's our adjustments. That's really it. We're gonna get this connected to the scope. That's the next big thing here. Oh, and I put some standoffs on here, and I typically do that on these smaller boards, so they're not sitting on the desk, and I run a risk of shorting something out. But it just makes it a little bit easier and better for me to be organized with them anyway. All right, let's get the scope out. All right, folks, we are at the portion of the video where we're going to go ahead and we're going to test this baby out on the oscilloscope as promised. To go ahead and power this device, we're going to use this BioNO battery. It's a 12-volt battery at 4.5 amp hours, which should be plenty of overkill for something like this. We're just going to go ahead and we're going to connect that up with a lead that I had made in a previous life. We want to be careful with this lead because these are not insulated, but that's okay because at the TheSmokinApe channel we like to live dangerously. So I'm going to go ahead and hook this up. Before I do, I want to talk a little bit about my oscilloscope probe. So the way the oscilloscope probe works is that you have this connector which goes to your ground or your common. Different people will tend to call that different things. So let's go ahead and connect that now. We are connected. Then each one of these white wires is a different waveform based off of a image or drawing or graphic, I don't know what you want to call it, on the board. I did not remember which ones are which before I put these in, so everything that we do here is going to be a surprise. My oscilloscope probe has a hook that I can open up, and then I can hook it right here, and then I can get a signal. But I'm not going to get a signal until I plug this battery in, which I'm going to do now. You can see the power light comes on, which is a good thing. And what we're going to do is we are going to switch to the oscilloscope view and take a look and see what we have. Okay, I hooked this up to the square wave, obviously, and then you can see that here. And I can adjust the square wave using some of the controls. Let me go ahead and do that now. I can roll in a picture of the different controls and what they do. When I go ahead and mess with these, this one is duty cycle, and it will adjust the duty cycle. So there's different things that we can do there. This control actually will switch the frequency range. So let me go ahead and just auto this in. Okay, before switching, what I wanted to show is that I added a counter here so you can actually see the frequency as I adjust it, and that is pretty cool. And as I mentioned, I can go ahead and I can switch the frequency using the switch that we put in here. Let's go ahead and change this to another waveform and see what we get. I'm not going to go through all the functions that exist on here, but again, that's pretty cool. Let's switch it there, and then I can also adjust these on the scope itself, but I don't necessarily know if there's a reason to. And let's go ahead and take a look at our sine wave. And again, I can adjust the frequency. And then look at that, really jump it up. So what I want to say is that, you know, I was able to get this kit and put it together with relatively low skills and not much equipment. And then I have a function generator or signal generator that I can play around with. And I can use it to learn things, all for around $8. And for me, that's pretty cool. Plus, I got to put together a kit, which occupied some of my time and curiosity. And you don't need to spend a lot of money to have things that you can use in your ham shack or in your lab to play around with and learn things. There are certain pieces of equipment like this that you can get relatively inexpensively and have some fun. Anyhow, if you have any questions, comments, suggestions, or recommendations, go ahead and post them below and I'll do my best to respond. Thanks, everybody. I appreciate it.